So we have the line segment between these 2 points, okay? And what we want to find is the coordinates of some midpoint, okay? So we want to find the coordinates of this midpoint M. And to do that, what we do is we produce a triangle. We draw a line through A, parallel to the x-axis, okay? We draw a line through there, parallel to the x-axis. We draw a line through B, parallel to the y-axis, okay, through the y-axis, until where they meet, and these are going to meet at point C, okay? So we have now a triangle that looks something like this, okay? Now, so based off the midpoint theorem, what I'm going to do is we're going to draw a line through the midpoint. We don't know the coordinates of it. It's some values, okay? So, but we're going to assume that this is the midpoint. We're going to draw a line through this parallel to the line AC. So we're going to produce this line through here, okay, over to here, okay? And what we're saying is the term says that this is the midpoint of this particular line here at BC. So if this is the midpoint of BC, okay, well then the distance between B and C, okay, the distance between B and C, so let's say the length BC, okay, is simply equal to, well, don't forget the coordinates here are this is x2, y1, okay. So the length from here to here is y2 minus y1, okay, that's that length here, okay. Now we know that this midpoint is halfway along here, so the midpoint, okay, the height of the midpoint above C must be at half that, okay. So actually the height of this midpoint must be, okay, the midpoints of this line here must be at, it's y1 up, okay, plus this distance here, okay, this distance half BC, okay. So it must be that plus y1, okay, which now gives us, I suppose what we have here is we have y2 minus y1, okay, plus 2y1, okay, all over 2, which gives us the coordinate here, okay, the y value, the height up, is equal to y2 plus y1, which is y1 plus y2 over 2, okay. Now we could have a similar argument. We could produce a line through this midpoint parallel to BC. So we could produce a line through the midpoint parallel to BC. And what this the converse theorem tells us is that this intersects this line segment AC. So that this length here is the same as this length here. Okay? But once again, the length AC is simply equal to, well, it's equal to this distance between here. Don't forget, C is x2 units away from the origin, okay, x2 units, and A is x1 units away from the origin. So this length AC is x2 minus the x1, so it's x2 units minus x1 units away. So that's the length of this. So the length of this particular segment here, from here to this particular point of intersection, is half of the length of AC. Okay, so actually it's half of AC is x2 minus x1 over 2. Okay, so now we know that the coordinate of this must be x1 units away from it plus the distance away. Okay, which tells us that the coordinate of this particular point here must be x2 minus x1. Okay, that's that distance here, plus x1, okay, which gives us, well, that gives us x2 minus x1 plus 2 x1 all over 2, which gives us x1 plus x2 over 2, and hence we have the midpoint, okay, of the line segment AB, okay, is given by we have the coordinates of AB, okay, coordinates of the endpoints AB, x1, y1, and x2, y2. So it's given by x1 plus x2 over 2 and y1 plus y2 over 2. It's a very simple formula to calculate what the midpoint is, but I suppose there's a little bit of work involved in actually rationalizing how we actually develop the formula itself. And this is just one way we could do this. Okay, there's many other ways that we could develop this particular formula. Okay, guys. Once again, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I hope that this video, another video in our series dealing with coordinate geometry of the line, and in particular the rationalization of where the midpoint formula comes from. The midpoint formula, okay, so the midpoint formula, okay, or the coordinates of a midpoint being x1 plus x2 over 2 and y1 plus y2 over 2. The rationalization of where this particular formula, or where this particular formula for calculating the midpoint of a line segment comes from. I hope that this was in some way intuitive, and more importantly, I hope that was helpful. So thanks for watching. Okay, bye bye.